Alright, for the last part, I almost forgot to get to the last page of this. We're going to look at this as an amplifier. So we're going to think of inputs and outputs. Well, where's the input? It's right here. Here's the output. How do you know it's the output? It's labeled, okay? Alright, how do we do this? Well, I see two transistors. We're going to shortly view this as a differential pair, but right now we're going to just review a little bit. Here's our input node. It comes in, we hit the base. Can we have the input of an amplifier and a base? Yes. Okay, where does it go from there? Does it go to the collector? Does the signal come out of the collector? No. It does come out of the emitter, and then it goes out that way. So I'm going to stop here first and I say, well, this is a common collector amplifier or an emitter follower amplifier. If you identify this as an emitter follower amplifier, then you know its gain, you know its R in, you know its R out. And remember, this set of terms is really all you need to know about an amplifier. And I mean, that's it. That's all we care about, really. Unless you're the one designing the circuit, then you care about what's inside the box. Let's continue on. Alright, so we go here. Signal comes in the emitter. Can we have signal coming in on the emitter? Yes, we can. Where does it go? It goes out the collector. So if it comes in the emitter and goes out the collector, that's the base. This is a common base amplifier, which also has a voltage gain. It has an R in or a Z in. It has R out. That's all we need to know. Okay. If Vn is going to be centered around 0, it says how should we set the DC value of Q1B? That is a typo, or maybe Q1 and Q2B. Let's assume that Vn is centered around 0 volts. If this is centered around 0 volts, we probably want this to be 0 volts. And if the base voltage over here is going to be 0 volts, R1 and R2, notice we have 5 volts and 5 volts. I want this to be 0. This is exactly half. That means these two resistors need to be the same. Now remember, there is a little bit of base current. That base current is going to make this node voltage go down just a little bit. This making these voltages exactly equal is only valid if we're going to make the base current to be 0. Where's the bottom of this go? That's our last question. This is a very large capacitor. Where does it go? Well, for AC, it doesn't matter. It could go here, tied to 0. It could go here, because remember, this will get eventually tied to 0 when we do the AC equivalent circuit. We could also tie this node up here, because this node will go to 0 when we do the AC equivalent circuit. So in one case, it doesn't matter. There are times when you want it to go to this node or that node or some other node because they're not exactly quiet. There is some noise and such at that node moving around. And if there was, that would inject current into this node through the capacitor, and that would be bad. That's what we have.